Hi there, my name is Ray Cazanese, and I am very excited to be here today at my first ever B-Sides Philadelphia. Thanks to the B-Sides Philadelphia team for allowing me to be here today to talk to you, and thank you for joining for this presentation. This presentation is entitled "The Cloud is for Launching Cyberattacks," and I'll start just with a little bit more about me and my team. I'm the director of threat research at Netscope. I have my PhD in electrical engineering from Drexel University, where I worked a lot on malware analysis. My background, in addition to malware analysis, is in software anti-tamper and, as of late, a lot more cloud security and using machine learning to solve problems in security. I've been in InfoSec for about 15 years now. And if you would like to follow me on social media, I've shared my Twitter handle here. And if you have any questions about anything I'm presenting today, or generally just want to talk cybersecurity, I've also shared my personal email address. Feel free to reach out to me there. For my team and what we mostly do threat hunting, threat intelligence, and threat analytics. And the data on top of which we're doing those things comes from our products that we sell. That being a secure web gateway and a cloud access security broker. And so the two of those, in the context that we're talking about today, are inline controls that provide us visibility into all of the web traffic traversing any device, and also very detailed analysis of the cloud traffic. And so, for example, that will give us activity level visibility. So the difference between a download from Google Drive or a edit of a Google Drive document or sending a Slack message or downloading an attachment from Slack. I'm going to share a bunch of figures and examples and trends. And so whenever I'm sharing information from the Netscope platform today, that's from 676 different organizations, a subset of our total user base, and about a million active daily users. And so I'll start with posing a question. And that question is, why does anyone use the cloud? And the answers to that are generally cost savings, because it's easy, right? It makes things that otherwise would require us to set a bunch of stuff up ourselves, a lot easier to use. The automation, the templates, the ability to deploy something in multiple environments very easily, and then the flexibility and scale that allows the organization. And so the other question that I'm going to try to get at the answer to in this presentation is, well, why would an attacker use the cloud? Is it these same 5 reasons? Is it something else? Is it the same 5 reasons plus something else? And so that's what we're going to get at today. I want to start just with some things that happened in 2020 from an enterprise security viewpoint. The first thing is the great work from home migration. This is coming from the Netscope platform, right? So this is based on just that subset of about a million users that I was talking about at the beginning. And in that subset of about a million users, we saw at the beginning of the year, about 30% of them were working remotely on the average weekday. And when that COVID-19 pandemic declaration came from the WHO in that week or two in March, we went from 30% of all of the users on our platform being remote to nearly 70%. And in the months since, that percentage is slowly climbing, right? So we've peaked around maybe 75% so far of people on our platform working remote. And obviously, when you go from an environment where everybody is in the office, right, behind some network perimeter, accessing things that are within that same network, to a situation where everybody's on laptops and iPads and Chromebooks and personal devices and you know, their cell phones and accessing everything from their home networks. There's some challenges that come along with that. The other thing we see happening in 2020 is just the continuation of a trend that's been happening for a long time, which is enterprise users are moving to the cloud for nearly everything. And so this is again looking at data from our platform from the past year. And what we see is last November, 88% of all of the users on our platform were using at least one cloud app every day. And over the past year, we've seen that go up 7 points. And today in November, when I'm recording this, 95% of all users use at least one cloud app every day. And so this is another challenge for organizations to deal with. And in the middle of this, this trend this year, we also saw a massive increase in the amount of usage of collaboration apps, things like Slack, things like Microsoft Teams, right? When everybody went remote, they also started using collaboration apps. And so when you start using collaboration apps, are you, one, locking them down appropriately? Two, are you ensuring that they're only being used for the things they should be used for, right? No, you know, maybe you don't want sensitive information being shared through your collaboration apps. Maybe there's separate channels for highly confidential information to be shared. And so lots of controls for enterprises to put in place to make sure things are being used appropriately. You know, and maybe one of the biggest ones from the past year being, how do you deal with private app access? Can your VPN handle it? Is your VPN appropriately, you know, secured? Or do you need a more sort of scalable, flexible private access solution? And so that's what was happening in enterprise security. But what else was happening in 2020? The other thing that we saw, and what I'm going to spend the rest of the time today talking about, is cyber attacks being launched from and against, in some cases, cloud applications. And specifically in these 6 ways. This is going from the left to the right, all the way across the kill chain. We're going to start with phishing, and we're going to end up with data exfiltration. And so let's just dive right in and start with phishing. And so I'm sharing a fun example. And the reason I picked this one was I'm hoping that somebody watching this today saw this attack and says, oh yeah, I remember when this one happened. This happened at the end of October, and it was pretty widespread. We saw it affecting a lot of people on our platform. What happens? Well, somebody shares a presentation with you, a Google Slides presentation, and they comment on that Google Slides presentation. And in that comment, they send a little message that in this case was a generic, like, hey, you've received something. You should click on this and get more details. This was not, I picked this one because it was so widespread and common, and I'm hoping that, you know, some of you here today have seen this. It wasn't extremely convincing. You know, I see a mail-d.xyz, right? As a InfoSec professional, I know that the XYZ TLD is widely abused by attackers. You know, maybe that's something that a organization might have just blocked outright. But there's some very interesting things at play here as well. The first is that this email made it to my and also made it to everybody else in our platform who this was targeted at, made it into their inbox, right? It wasn't labeled as spam. It wasn't labeled as potentially malicious. It wasn't labeled as an external message, right? It was just in their inbox. And the reason is because it's just a comment on a Google Doc. And so I have this square at the bottom left of all of these slides that's asking why, right? Why use the cloud for this, right? And so why use the cloud for phishing? Well, number one in my list of why is to bypass email filters. And that's exactly what this did. Number two in my list is exploit the user's trust. And so what I mean by that is I use Google Slides all the time, right? Right now, I'm recording this video of me presenting to you a Google Slides presentation. In preparing this slideshow, people on my team reviewed it and made comments on it, and I got emails just like this. And so what I'm saying is that attackers are using apps that are popular among their victims and are trying to use them in a way their victims probably use them as well. And so we see an awful lot of this, right? This is just one example, but this is one of the most common things we see attackers using the cloud for. It's Google Drive, it's Dropbox, it's Box, it's all of these cloud storage apps that allow you to share documents with other people and using them to try to, try to get past those email filters and convince the user to click on something. Before I leave the phishing topic and on to the next one, I also want to talk about sort of the other angle here, right? So the last slide here, right? This was phishing from the cloud. And so now I'm talking about phishing for cloud credentials. So this picture comes from APWG, the Anti-Phishing Working Group. They put out a quarterly report of trends in phishing. And what's been happening for the last few years is that a big slice of this pie has been phishing for cloud credentials. And you can see it here, right? SaaS and webmail, cloud storage and file hosting. It's more than 36% of the total targets for phishing. And so this is just showing that attackers are going after cloud credentials. And again, let's ask that question, why? The why is because that's where the sensitive data lives, right? Especially in these webmail apps, right? If you can get access to somebody's webmail, you might find VPN credentials. You might find out what apps they're using. You might be able to reset their passwords for those apps, right? So getting access to webmail is still extremely valuable. And so let's move to the next one. This is sort of, moving in order of the kill chain. We talked phishing, ways how to get emails into people's inboxes and convince them to click on something. Now let's talk about the Trojans. Maybe this is one of the things that the attacker was trying to get them to click on. I'll begin with another figure of some statistics from our platform. This is showing some file types and the prevalence of those file types in the universe of malicious files that we are detecting and blocking on our platform. And this first one is the one I want you to focus on. Office documents before, and when I say before here, this is before COVID, right? So this is in January, February, early March. We saw about 5% of all of the malicious files that we're blocking on our platform were Office documents. Over the summer, we hit a point where it was nearly 45%. So just a huge increase in the number of malicious Office documents that we were seeing. These were all Emotet related. And you'll say, what are you talking about here, right? We were trying to talk about Trojans, right? So that's what I'm getting at, right? I just wanted to share that context of like, this was happening in massive numbers. And what was happening was this. So the Emotet crew is sending these emails. These emails are typically look like replies from real people, in many cases because they are replies from real people. This is the Emotet crew leveraging compromised endpoints and compromised email accounts that they already had to send these messages. And so you get this message. It looks pretty good, right? It doesn't look like the other message I just shared. You've received an important notice. Please click on this link. No, this is it's got a confidentiality notice. It's from a real person. If I looked up their email address, I would find more details about who this person actually is on the web. It has a download link in the email to download a Word document from Box. And we saw Box used a lot in these Emotech campaigns that were targeting people on our platform. You download the Word document from Box and open it in Word. It would ask you to enable macros, and you might say, "Oh, macros! Who uses them anymore?" People who work in the enterprise today, right? Macros are still a feature, right? Because they are still widely used, right? So lots of people are used to allowing macros, executing macros. They see something from somebody they trust, they run it, it executes a PowerShell script, and the PowerShell script downloads a payload. And it's the same. We saw the same pattern in so many different variants of these emails and these Emotet Trojans. It was always open it, and you see like the process execution visualization below. Open it in Microsoft Word. It, through an RPC, launches using WMI, PowerShell. PowerShell is then going to reach out and grab that next stage payload and download it. And so, same question I'm asking in all these slides: why? First thing, right? Why are they doing this? Let's bypass the email filters again, right? Really, really clever to use real email addresses, real people's mailboxes. And again, they're not attaching, in some cases they were, but in this example, they're not attaching the malicious file. They're sharing a link to it on Dropbox, right? So other ways to get through the email filters. And again, most of these messages were ending up in people's inboxes, not caught by any of the filtering solutions they had in place. And number two, exploit the user's trust. I know this person. I receive emails all the time from them, or emails like them. I receive Microsoft Word documents all the time. I use Box all the time, right? All this stuff looks legitimate. That's reason enough for me to click on it, open it, and see what's in there. So, we're talking Emotet, right? So what's Emotet's goal? Eventually, right, to download some malicious payload. And so let's talk about malware payloads, but let's talk about a different example just for fun. Let's talk about Gooloader or Gooloader. And so here I just have a screenshot of the indicators that we pulled out for one of these samples that we detected from our sandbox. So this is one that a sandbox picked up. And you see, first off, this is fun, right? Gooloader had what I like to call the kitchen sink of anti-analysis techniques in there. So you see this, somebody's obviously got something to hide here, evading debuggers, doing other things to avoid being analyzed by things like my sandbox here. I can see, that they're trying to execute something, right? It's creating new processes, it's creating system objects, it's writing memory pages and labeling them as executable, right? Clearly trying to execute something. And what is that something that they're trying to execute? Well, it's a document here that they're downloading from none other than Google Drive. And so this Gooloader was extremely popular this year for Emotet and Gooloader, probably the two most common downloaders that we saw on our platform, meaning like saw people actually falling for it and trying to download these things. And the question comes up again: why, right? Why do it this way, right? Why is it significant to try to download your next stage downloads from Google Drive? Well, you saw in my earlier example, I said I'm an InfoSec professional, right? And so when I see a message from Google Drive saying click on this link, mail.xyz, I'm like, no, that's almost certainly nonsense, right? I could probably even block .xyz and be good to go here. So there's a lot of web filters that work that way, right? They block TLDs or they block domains that are suspicious or newly registered or not popular or are explicitly on some threat feed that says you should block these. And so use Google Drive, you bypass all those web filters. And you also probably bypass a fair number of enterprise security products that do filtering that way. And so that's the why, right? You've sort of got this far. Why blow it by trying to download the malware from somewhere that's likely to be blocked? No, instead try to download the malware from Google Drive or somewhere that's almost certainly not going to be blocked. And you'll be able to get these payloads into those enterprises you're targeting without any issue. And so now that we've got a payload running on a machine, let's talk about some of these different types of payloads that we've seen. And let's start with credential stealers. And so the credential stealing story is very similar to the phishing story that I told with that graph from APWG, right? What are you trying to steal credentials wise? Well, banking passwords, that sort of stuff, right? But also cloud credentials. The why, that's where the sensitive data is, right? The same reason why phishers are after cloud credentials. And so what we've seen credential stealers doing is generally trying to steal everything from the browser, right? With the intention that your cloud app credentials are going to be in your browser password store. But also, quite interestingly, stealing things from your file system where certain apps store their credentials. So for example, AWS stores credentials in .aws/credentials. That's stored in plain text in the user's home folder, right? So if you're running on that system, you can grab those credentials out. We've also seen quite a bit of trying to steal webhook, OAuth tokens, right? API keys, anything that you can steal for any of these native apps that are running on, the customer's machine. One of the examples that I use here is if you're using Google, the G Cloud utility, and you run that G Cloud auth command, and it takes you through the OAuth flow and opens the browser, and you click OK, authorize, and all that fun stuff. What happens to those credentials? They get stored in a SQLite database, plain text on your machine, right? So credential stealers can go after those credentials as well. I pointed out, these AWS, these GCP credentials here because it's another sort of end game for attackers. So I have the why here, right? That's where the sensitive data is. But with things like AWS and GCP, the why is also, well, that gives me access to infrastructure that I, one, don't have to pay for, and two, might be able to, hide underneath stay under the radar there for a while. You can use those credentials to spin up infrastructure to launch additional attacks, right? Or host payloads for additional attacks. So that's another reason why to go after things like AWS and GCP credentials. And so next on the list is command and control. And so the example that I want to share here is a malware family called Slub. And this is a malware family that has been around for a while. We see sporadic attacks that use it. And it works generally like this, right? Step one, grab some commands from a GitHub gist. Step two, run the commands and post the responses to a Slack channel. And then step three, if the command is to grab some files, upload those files to file.io. And so what's happening here, right, is like GitHub and Slack being used as a command and control server. And I have a URL here, which is a link to a POC that shows just how easy it is to do this, right? You can do this really in any app, but certainly messaging apps like Slack are really nicely suited for this type of messaging application. And the why, right? Number one, bypass the web filters, right? I mentioned it before, right? It's easy to block .xyz. It's easy to block malicious domains, right? There's a lot of enterprise security products that rely on web filters. There's also, if you're talking about like IPS, IDS, the IPS has a lot of signatures that are built to detect all of these custom command and control protocols and implementations that attackers have made over the years. But if your command and control channel is just posting Slack messages, what's the IPS signature for that, right? So being able to get around some of these enterprise security products by doing something like using a chat program that everybody in your enterprise is already using already, you're going to blend in with everything else, and it's going to be really hard, for something like an IPS to detect it. And so this brings us to data exfiltration. And this is my last example. This is a fun one that I chose, not because it's being launched by sophisticated attackers, but rather because it's not. This was pretty widespread. We see a lot of it. It's happening in Discord. Looks like, very ad hoc, mostly script kiddies. And they are going after their victims' cloud credentials, mostly Discord. And so what happens, they target the user with the malware, which is hosted on Discord and GitHub. Once it's on the machine, it is a credential stealer. It grabs the credentials from the web browser. It also looks for Discord credentials for the native app. And it posts all of the credentials that it steals in a Discord message that it sends right back to the attacker. And so again, I shared this one. I've got a blog post on it on our blog if you want to go read more about it. But I shared it because it's a pretty easy one to decompose, take a look at how it works. Source code's posted currently on GitHub. Who knows if or when that will get taken down. But something that you can get your hands on and see how this works. And the question, why, right? Why do data exfiltration this way? Number one, bypass web filters. Like we've been talking about, right? If you use Discord, hard to say, let's filter out Discord. And again, IPS signatures, other things that you might have relied on for detecting data exfiltration aren't going to be very effective when you're trying to detect a needle in a stack of needles, right? That Slack message that was bad versus that Slack message that everybody else has been sending all day long. Okay, so that was the 6. So let's recap a little bit. Why does anybody use the cloud? Cost savings, ease of use, automation, flexibility, scale, right? Same reasons attackers are using the cloud, except there's more, right? In addition to that, we identified them as we went through. Bypass email filters. That's how you're going to get phishing messages, messages to deliver Trojans into the user's mailboxes. Bypass web filters so that when they're clicking on things to download next stage payloads, when they're sending command and control messages, when they're exfiltrating data, that's not likely to be gobbled up by a web filter if it is using the same apps that organization typically uses. By the same token, right, bypass other security products, and we talked quite a bit about IPS. Exploiting users' trust is a big one here for the phishing, for the Trojans, right? The idea is users are used to using these apps these days, right? They're in the user's face all the time, and you can see it with what the attackers are doing, right? What apps did they pick to use? All the ones that are the most popular. And then finally, that's where the sensitive data is, right? So why use the cloud? Why go after the cloud? Well, because that's the data that you're going after is hosted there. Ransomware has been big business this year for attackers. right? You know, very traditional ransomware going after endpoints and encrypting endpoints. But, you know, if you want somewhere else to go after data, cloud is where a lot of data lives. So, what are attackers using the cloud for? We identified those 6 things, right? From phishing through to data exfiltration. The most popular techniques we've saw this year were at the beginning of the kill chain. So phishing, Trojans, malware payloads, credential stealers. That was the stuff we saw most commonly happening in 2020. Just diving in a little bit more on the apps that we saw being used and abused by attackers. These are the top 5, right? Box, S3, OneDrive, SharePoint, and GitHub. They make up about half of the malware blocks on our platform from the cloud this year so far. The other half come from 120 other apps that I didn't list in this figure. So a huge wide array of apps being abused to do all of this, but the most popular apps being abused, also very popular apps among the general populace. So if I go and I look at those last 2, command and control and data exfiltration, we are predicting that we will see an increase in those 2 happening over cloud apps in 2021. The reason is that we've seen enough examples that we expect that other attackers will emulate, that we'll start seeing this in mass, right? It always takes a few trendsetters to try these things out before everybody just starts copying and pasting their code and reusing it in all of their new malware samples. And so because these early ones were heavily reliant on collaboration apps, right? Especially Slack and Discord, those chat apps we saw used quite a bit. We expect to see a rise not only in these, but a rise in these specifically abusing collaboration apps. But we do also expect that we'll see some other stuff happening as well. We expect to see other types of apps being used for command and control and data exfil and being used in new and creative ways. One example that we just saw happening recently was draft email messages being used for command and control. So, you know, as people try those out and see successes there, we'll see more and more of it. But 2021, huge rise in collaboration apps being used for those 2 techniques. And so that's it for my presentation. Thank you for joining me today. Thanks for taking the time to talk about how the cloud is being abused and being used to launch cyber attacks. Again, right, we talked about these 6 techniques, everywhere from phishing all the way to data exfiltration on both ends of the kill chain. I've shared here again my Twitter handle and my personal email address if you'd like to reach out to me on social media or send me a DM if you want to talk more about anything I talked about here today, or really anything in cybersecurity, especially cloud security. Always happy to talk security with anybody. Thanks a lot. Cheers and enjoy the rest of the conference.